are 500 people, 4 offices. Across 4 offices, we have 50 nationalities, speak 45 languages. So we have quite a wide collection of cultures that really enable us to work quite seamlessly across the world. As you can see in the map, we mostly work in Europe, North America, Middle East, China, Southeast Asia, but also in India, of course, where we are designed Navi Mumbai. Zaha founded her practice in '79. Office was very small at the beginning, and through a lot of effort, she really became at the forefront of architecture through her personality and through the help of her collaborators, where she's been and our company has been for now for nearly 45 years. So she passed in 2016. But because many of us have been with her from the beginning and stick with her through quite hard times at the beginning and through the growth of the company to what we are now, we are proud to carry on the DNA. So really the work through her inspiration and after her passing hasn't really changed substantially. It evolved along the same path. We were talking about challenges earlier with the previous panels. We really find challenges, what really drives us, so embrace challenges. We are still at the forefront and still global leaders in research and design, and we diversified the way we work through the years to make sure that R&D component is really always thriving. Cultural projects were our bread and butter at the beginning, especially really focused and specialized on those from the very early onset, but then we work a lot on large mixed-use office, corporate, and HQ, headquarters, transport and infrastructure. Sometimes people maybe the audience is not sometimes that aware, but we work a lot on that too. Bridges, train stations, airports. We designed Dashin Airport, which is the largest single terminal airport in the world in Beijing. Resi buildings, a lot of hospitalities. We did work with Taj on a hotel, for instance. Sport, we designed and built the aquatic center in London. A number of stadia, especially the one you see at the top there on the far end there, which is one of the stadium we designed for the recent World Cup. Civic buildings, education, schools, cultural centers, master planning. From the master plan, we get to actually design and build it throughout, which is obviously an amazing experience. Retail, so scaling down a lot. Exhibition and design installations, which we love doing as well. Some of these pieces, for instance, are various biennales in Venice. At the top there's our exhibition in the Guggenheim in New York. We really proud ourselves of doing is disseminating knowledge, and I don't mean only internally within our company, but also we really love working with contractors, exchanging ideas with contractors, and I think we pride ourselves of really having contributed, obviously with other practices as well, to grow certain markets, in particular China, for instance, where we've been working for 25 years. In this instance, for instance, this book is an internal handbook that we distributed to all our staff, where we encourage them and explain them how they need to incorporate low carbon strategies from the very onset of the design, how to design resilient buildings, of course, designing buildings that are already future ready for climate change, how to minimize the use of concrete or any high energy consuming material, and incorporate renewables, but always in a way that is really seamless with the architecture. Not only in buildings, but also in public spaces. For instance, just an example, flood defense system that we designed in Hamburg. So how do you make these elements that are defense systems into public spaces? How do you incorporate these topics in infrastructure? This one is, for instance, a new metro line station for Oslo. Approach towards infrastructure and transport is always very public space driven. So our stations are first and foremost public spaces, but also environmentally conscious. For instance, we work a lot with this case and other ones as well, making sure that stormwater is managed, making sure you incorporate as much as possible permeable surfaces. Passive systems, of course. This one is a project we just opened at the end of last year in Sharjah in the UAE, and it's been completely designed towards being a highly sustainable passive building. Every piece of glass is shaded. There's a lot of opaque surfaces, but still a very good natural light level inside, for instance. Integrating renewables in the facades, solar panels integrated in facade and roofing. More kind of specific systems incorporated in large buildings like this one, the Dashin Airport, ground pump systems, water management, and also throughout photovoltaic panels cladding. Or on a smaller scale, this one is a project in Oxford. We did for Oxford University, it's a library, highly sustainable building, ground source heat pump included, and cross ventilation solutions and so on, to make sure that everything we designed is really future-proof. We're not only talking about design as in economics and environmental, but also social. So the social sustainability agenda for the UN, the target that UN has for 2030, this is something we try to take on board as much as we can. On the social side as well, so not only on those two pillars that I mentioned, economics, environmental credentials for the building, but also the social. And we do this by trying to, as much as we can, to develop the project together with the client from the start and getting involved at the onset when the client is developing their own brief. So when the client is sort of deciding what they want within the project, we always try to make sure they incorporate elements of public space, that this project, whatever the project is really, whether it's private or public, really gives back to the community as much as possible. Now I'm going to explain more about the kind of support teams we have within the company that enable our design teams to do what they do. In particular, this one is called ZHA Code. It's a focus group within our company that is focused purely on R&D and creating tools for the designers, and in developing particularly structurally aware geometries and robotic fabrication they're very strong on, and industrialized construction. So this will help the design team not only design in such a way that is fabrication conscious, but also further down the line finding the right contractor, the right way of fabricating whatever that is, from the small installation to large elements. So some of the techniques they use, tensile structures, hot wired cutting, curve crease folding, self-standing structures that are merely structurally relevant because of their geometry and their folds. All this is supported by a bespoke computational framework, and this framework is really incorporated seamlessly in daily workflow of all our staff. Targets that we have set ourselves with this group are those that you see on the screen. Developing manufacturing technologies and responsive design. Responsive design, I mean responsive to not only the client input, but also the final user's input, and I will show an example briefly in a minute. Modular construction, which is very important for sustainability, so modularity and generative design. Gaming technologies, and again I will show an example why gaming technologies are important in the sense. Participatory design, so making sure that there is as much as possible audience participation, whether it's final users, whether it's final buyers, or whether it's even neighborhood associations, stakeholders within the project, and so on. This sort of process is not only within our company, so we are not kind of working in isolation. We're working very much in connection with universities in a very non-formalized way. So we didn't set up partnerships or anything. What we do is that everyone, Zaha used to teach in various universities. She was at Harvard. She was at the Architecture Association in London. A lot of us come from there. In particular, for instance, I studied at the AA in London, Architecture Association. So there was this seamless discourse between university and practice, simply because she was teaching there, then Patrick Schumacher, our principal, was teaching there, and a lot of us have been teaching and studying there. So there is communication between our company, so the giving, let's say, of our company to the universities, but also the coming back of the knowledge in the form of students. In particular, this slide is focusing on responsive environments and housing, which is something that we've been working with the AA across 20 years now, and not only on academic level, as you can see here, but then also within our company in certain projects. For instance, I'm just showing an example here of a project we did in Honduras, where together with former students, they were working on that for their thesis. We developed a participatory design in which technology is used to foster user-focused design. And I will explain briefly how. It pretty much is a bottom-up approach. So what we want to do is to create tools for end users or buyers, in this case, these houses, to be able to customize from the beginning, but within parameters. And these parameters are, of course, the client's expectations in terms of budget, But not only that, environmental parameters, making sure that the project is hitting the correct certification. So this is a platform you see here for online consultation. We use Unreal, which is a gaming software, combined with the custom C++ scripts done within our company to develop this platform, enabling participation, enabling the end user to contribute to our design by making choices, so choosing which elements they want to combine in which way, how big the house needs to be, where the bedroom should be, or the module hosting the bedroom, where, views, how orientation, and so on. And but then this is translated seamlessly within the work of our practice, because we use the same sort of responsive and parametric tools. At the same time as the user is making their choices, we can update our work because we work in parametrically. This shows the library of building of parts, these components that are available for the public. We're always working with local materials. In this case, for instance, mostly timber because of the location. In Honduras, it's in the middle of a forest. We're using local timbers, but not only local materials, but local fabricators and local contractors. So we never, ever, I'm not aware of any project we've done where we impose the client to use a contractor from abroad or European contractors, whatever. We always use local ones. We do quite a lot of research, helping the client finding the right contractor, but also we do a lot of work with contractors, technical team, to make sure that they are using a workflow which is compatible to ours and vice versa, so we can really contribute throughout the process until the fabrication is completed. And of course, modularity is not only modularity in terms of housing and big kind of elements and components, but also smaller components. Like for instance, this one is a prefabricated bridge that we designed and built for one of the biennales a few biennales ago in Venice. And it's entirely concrete printed. And of course, the advantages of 3D concrete printing is that there is a level of reduction of redundancy, but also you can basically be modular without being a cookie cutter. Of course, you can have modularity, but you don't need, modularity doesn't mean to be self-similar. Like for instance, I don't know, when you build using molds, then the key element would be all molds need to be the same, so that you cut down costs, but then every element you're producing will be the same, for instance. In this case, when you work in 3D printing, this is no longer relevant. The modularity is there, but every module can be different, and that doesn't really add to the cost. And of course, you can still work, like in this case, with concrete, but it could be recycled concrete, so you can contribute to the reduction of overall embedded carbon footprint of the project this way. But another thing we would like to do is work a lot with vernacular. We love looking at ancient techniques and understanding how we can use them again, stretching them maybe to the limit and upgrading them with current capabilities in terms of fabrication. This one is a project, for instance, that we did with the ETH Institute, with the Philip Bloch group in Zurich. Again, it's for Venice Biennale, and it's a vault which is constructed using the exact same technique that you would see in European Baroque vaults. So really the vault stands purely by virtue of its own geometry. There is no mortar and there's no reinforcement, nothing. It's really constructed as you would imagine these vaults being constructed in the 16th century. This one is another one. Here the geometry is slightly different, so this one requires a minimum of reinforcement, same system, and all the stone block there you see is 3D printed. But then if you want to scale this up, the choice of material really determines what you can do in terms of innovation, but also in terms of reduction of carbon footprint, also in typologies like, for instance, in this case, Stadia, that are known to be accountable for 80% of the carbon footprint of their own industry. This has improved lately, but until a few years ago, that was the case for Stadia. So Stadia, acting in Stadia and reducing the carbon footprint of Stadia largely reduces the carbon footprint of the entire football industry. So in this case, of course, this is not a huge stadium. It's a 10,000 spectator stadium, but it's entirely designed and built in timbers in order to be sustainable at the source, but also fully recyclable. Another way that we have of using AI, artificial intelligence, is to try to help us in terms of analytics, whether it's laying out the furniture in the optimal way in a headquarter, or whether it's designing cities. We use these tools as a prop. There is a lot of talking about AI lately, and there's a lot of talking about AI being able to sort of take over the job of a designer. I don't think we're not designing by AI. We're not like inputting and getting the final result from a artificial intelligence engine by any means, but we do use it as a support, and I will try to show how. We use it a lot in spatial analytics for instance, headquarters. This is the Allen curve, and what it says, the frequency of communication, obviously, is much greater with closeness, quite logical, but it's been measured, let's say, scientifically mapped. We created and run an algorithm that determines the shortest path between co-workers. And if you see in the two examples, how the sort of desk layout is really making a difference in terms of communication. So you have the same amount of desks on the left and the right, but the linear layout of desks is actually contributing much less to cross-communication than this organic one. That's been measured, and that's why we abandoned this sort of like row of desks in favor of different configurations. Even pulling furniture apart, we tested that in the same amount of square meters, if you pull desks apart, you get 70% more interaction. This is a tool we're using to measure distance. So simulated desk layout within one of our floor plates, and then we run these tests to see which areas are the most interesting in terms of say, communication, and where you could potentially put a team, allocate a team that has much more of a need to work with others and which are less. In this case, for instance, it's quite clear that the corners that are normally areas dedicated to the top managers are completely devoid, nearly devoid of communication, which is good if the top manager doesn't want to work with their own team, so it's obviously very bad in terms of interaction. So if a company where the top management is very involved with the work of their teams should obviously reconsider this. And we're measuring how many people are in reach of meeting tables, for instance, but also what we do, which our clients find very interesting, especially for headquarters, is that we will first start mapping the client's ID. Who is the client? Who are their teams? And how do they work together? Whether they work in isolation, how big they are, with which other teams they interact, and then we'll use this sort of information to understand in the floor plate which is the best location for which team. So let's say the team that has got more of a need for networking will be placed in the area that is more accessible. But visibility is a very good parameter as well, because it's not only about physical distance between people, but also who I can see. So if I'm working on a large floor plate like this one, it's a proven fact that if I see people, I will I will remember that I need to do something with that person. I will interact more, and if I don't see these people, or whoever, if I don't see people, then the interaction will be much less. This is a tool that we created where basically maps the impact of the position of a core within, of a stair and lift core within a building in terms of natural daylight, visibility, and views. So this analysis will tell us, okay, if I put the core, let's say a center core will give me these results in terms of interaction, natural daylight, which is obviously a great factor to reduce carbon footprint, because of course you want less and less artificial light if you can. If we were to run this study by using AI, as we do, we get in 27 hours of processing, we get 100,000 options. So we will really be able to identify which is the best. If we were to do this by hand, let's say, we will develop maybe 40 options per day. It will take them 10 years. I think this shows why AI is really helpful in terms of in planning terms, because it really speeds up processes. You'll see the position of the core, and then you see mapped on the box diagram or the cube diagram. At the end of it, then we can identify, okay, this is the best layout for these parameters, and then start working with it. We're not really starting off with AI and then let AI determine our flow plate. When we design towers, for instance, we start off with the concept, which is driven, what you see here in the images, it's driven by completely different parameters. It's driven by what the client wants, the client budget, obviously what we expect the site to look like once the design is done, and how it contributes to its surrounds. And then at the same time, we discuss and try to find optimal flow plate. So it's a give and take between these two. This one is a headquarter we designed in Guangzhou in China. And here this shows how we run the same type of AI tool to identify which is the best position for the atria. Of course, the flow plate was going to be very deep, so we needed atria. We tried to position them exactly in such a way as for them to contribute to daylight, for instance. And then how you locate the cores, again, to try to optimize daylight and optimize an interaction. And then how, again, you identify where to position that have a longer occupancy during the day, so they need more daylight, and which areas you need to put, locate elements that are not so needy in terms of daylight, meaning temporarily used formal meeting tables and so on. Least visibility, you have more, we work with more like focus work, like maybe smaller meeting rooms or location for those that need to be working in a more quieter way. And most visibility we normally dedicate for informal meeting areas, collaborative work, or even breakout areas where people can both enjoy a bit of spare time and have a chat, but also do informal work. Location of teams, interdependent teams where the interaction is higher and independent teams where the interaction is lower. What happens is that once you have this behavior plotted onto the flow plate, then you can really design furniture configurations that suits the use. So whether it's focus groups, whether it's group work, whether it's informal meeting, whether it's breakout area, and locate them in a way that suits. This is miles away from 70s or 60s bureau landschaft where you have this kind of a big carpet of desks and everybody complaining about noise. This is a master plan we designed in Chengdu, and we're building at the moment in Chengdu in China. We started with the master plan all the way down to designing the buildings and construction drawings and so on. The design team had this idea that because the master plan with only a few towers and with a lot of low-rise office buildings, so large flow plates, they had this idea of elliptical distribution. They did curves and how the curves would sort of allow for a very kind of wavy circulation across the side. So they had the idea of the ellipses, but then we used AI to determine the best possible configuration and grouping of ellipses. So again, the same to try and find best possible combination of ellipses that will give us best daylight. It's just an example of what the AI came up with in terms of mapping and then trying to focus on to the best outcome at the top of the graph. We picked those shapes and we started working on them as architects, right? AI came up with this and then we'll develop them further and really make them into something that works. We also use the game, this time not for form finding or clustering of buildings, but for circulation on site. We developed a artificial intelligence driven game that we let our staff use. So our staff would use this game and the AI, the artificial intelligence engine, would learn from the staff use. So instinctively direct themselves left or right, and then at any crossroad, any fork, and the artificial intelligence engine will learn from that which are the areas or which is the sort of triggers that will lead people to turn in one direction or the other. So it sort of mapped this element, and we started understanding how people navigate space and what leads them from A to B, and what, without having any sense of program, what would encourage them design-wise or visually to go from one place to the next. And then we found out that in most cases, people were attracted by sort of low-level buildings in the close-up and then higher rises in the distance. So having this sort of like long-distance target would attract them to go in that direction. And we tried to use this to sort of create a system where potentially users could navigate the site in a very instinctive way. And obviously the client would then, on the basis of this analysis, really understand where the highest footfall would be. So where most of the people we could naturally congregate and use those areas mapped in red here in the plan for retail, public spaces, and so on. So making the most of those areas and making the most of the quieter areas for other users. So this one is the master plan now being completed. You can see it being built on north side. So I just wanted to conclude saying that yes, algorithms definitely help us evaluating and analyzing, finding best practices, but then finally, obviously, we as every other architect, we will draw our own conclusion and we will make the best of this outcome. We'll never let AI drive the design, so to speak. Thank you.